So I'm going to talk to you tonight last about the company I founded and I run, which uses mushrooms, as you can probably tell from my logo here, to transform agricultural waste products into a cost-competitive alternative for plastics. And this is something I've been working on for the last 5 years. We've reached a reasonable level of scale, and our goal is to eliminate styrofoam. But before we get into that, I want to talk more broadly about what I think one of the big challenges facing us, certainly in the next few years, the next 100 years, and we've heard parts of it this morning. And it's marked by the transition we're making, at least in the field of natural resources, from abundance to scarcity. And the question that's been in my mind, and I think it's bubbling up into the consciousness, is how do we create systems that breed abundance from scarcity? And if you think about our current economic system, our socioeconomic system, our culture, for the last 200 years, it's actually bred abundance from abundance. 200 years ago, there were millions of people on the earth, not billions. We had lots of trees, clean water, oceans, natural resources, and we converted this into a tremendous amount of wealth. And we did that through compound growth, through debt, through technologies and products we created. But it came at a real big cost, right? The cost was waste. And you only see the symptoms of this when you transition from abundance breeding abundance to scarcity. And we're seeing this with water now. We're seeing this with our forests. We're seeing this with oil. And we're discovering that this system we've created doesn't work. And we've been trying to bandage it, trying to change it in other ways. And it's really not working, because we need to be brave enough here to actually reimagine, to reinvent, to totally rebuild our industrial economy, right? We have to start from the bottom. The systems don't work. We need solutions that breed abundance from scarcity, right? We need solutions that replenish our planet, whether they're products or materials, through their use, not drain it. And you're starting to see this. We heard about this in the idea space today, about how IBM was able to do this with the commons, right? They worked with open source software, and they formed a mutual relationship where the community benefited and IBM could build a great business. And we're seeing this start to bleed over. There's a new app that was launched in Amsterdam 2 months ago called Peerby. It's like Twitter for things. You need a lawnmower, you type it on your phone. It reaches out and finds your neighbor with a lawnmower. So just like TaskRabbit, maybe we can change the way we consume and buy things. You need one lawnmower for a community, not 20. But the truth is, until we transcend into our iPhones, we actually live in the real world, right? We need real stuff. So we also have to be brave about reinventing and reimagining how our industrial economy functions. How do we create products and materials that become nutrition, not pollution, at the end of their life? And the challenge here is partially technology. And I believe, and what I want to share today, is that the technology we need to do this has actually been staring us in the face. And I want to start with an example, actually, from a group of Stanford MBAs who created a new consumer appliance. And they did this as a thought experiment, but they couldn't create it in the end because they didn't have the technology. And I bet most of you, by the end of this, will realize what the technology I'm about to show you is. So these Stanford students did a study, and they said, trends show that people love fresh food. The fresher, the better. Farmers market's good, delivered to my door, even better. They also love coffee machines. So they got in their MBA circle and they brainstormed, and they came up with the idea for the Ematic. So the Ematic is a device that sits on your counter. You get your little egg pill, right? It's half starch, half water. You wake up in the morning groggy, and you put it in this machine. You put your egg cup in the machine, and it vibrates, and 30 seconds later, out pops a fresh egg. And these MBA students were trained. They made a prototype, looks like, feels like, brought it around to people and said, would you like to buy an Ematic? People said, yes! I would love to buy an Ematic. This sounds great. I'll buy 2. I'll buy 1 for my grandmother. Fresh food, it's like a Keurig machine. It's a dream, right? So they said, we're on to something. So they went to talk to scientists, and they talked to engineers. These folks said, you're crazy. You can't build this for a consumer price point. You can't convert starch and water into an egg once a day. That's like magic. It costs millions of dollars. You need a giant factory. You need synthesizers, extruders, processors. It'll never happen, right? So the Stanford students went home. But the truth is, everyone here knows how you convert starch and water into an egg, right? It's in the box. It's a chicken, right? I think we need audio back there, by the way. Now, I mean, I'm being facetious, but actually, if you think about what a chicken does in the context of an appliance, it takes starch and water and makes an egg every day, right? And it's sort of a byproduct. It goes around and eats bugs. It talks to other chickens. It's not even its like primary responsibility. So Arthur C. Clarke has this great quote. Any sufficiently advanced technology is indistinguishable from magic. He was talking about the cell phone in your pocket. He was talking about GPS. He was talking about these wonderful technologies that he predicted and we created. But when I look at a chicken, I think that's one freaking magic chicken. Great technology. So at Ecovative, we think of this concept as bioadaptation. And it's actually about thinking about how do you find the technology in nature, the living system that performs the task you need, to substitute into our industrial economy. And we've done this using a property of mushrooms known as its root structure, or mycelium. And mycelium is almost like a growable plastic. The root structure of mycelium is incredibly fibrous, it's incredibly small, and it extends throughout a medium. And it turns out when you analyze mycelium, it has many of the same properties of a plastic. It's actually a naturally occurring polymer. And what we did at Ecovative is we didn't try and extract the mycelium from this organism. We didn't try and grind it up and take the mycelium and run it through an industrial extruder, right? That's how people have been trying to make cost-competitive plastics for years. We said the mycelium is the plastic. Its intrinsic ability is to be a glue or a plastic. We're going to use it as is. We're actually going to grow mycelium directly into the product we want to replace. So at Ecovative, we replace these types of styrofoam corners with a mycelium equivalent. And we actually grow these in place. This is the same corner block. You can see these white dots. This mold is filled with ag waste. Mycelium doesn't like to eat starch and foods that humans eat. It eats things like cellulose and lignin. So we go to farmers and we buy their corn stalks, not the corn. We'll put them in a mold like this. We'll add these white little cells. And if you watch, this is a time lapse of 30 seconds, you can actually see the mycelium growing throughout this part. It's digesting the ag waste, and what it doesn't digest becomes embedded in the matrix. So it becomes a composite, kind of like concrete, with the mycelium being the plastic holding it together, and the food source being the structure. And what's exciting about this is we grow it all in one step, right? We grow mold these things. And we have lots of equipment and machines in our factory, but the machines are about augmenting and accelerating what the mycelium does naturally. They're not about extracting and redoing what it does, like you do with biomimicry. So I started this company 5 years ago with a co-founder, Gavin McIntyre. We started this in the basement of the business incubator at our school. I need to get more shirts, I guess. But this is really about, internet companies, right? So we did lots of things you shouldn't do in a carpeted business incubator, like lugging buckets of water down the hallway, running pressure cookers in our little office space, and lots of bad things. And I think we held the record. In fact, we were the only people that had the fire department come to the business incubator again and again and again. And I have this one memory of standing outside in February, and it's like a 5-story incubator, and everyone's out there, they're cold, and it's like me and 2 other guys on my team, and we're sort of huddled to the side. Everyone else in the business incubator is just looking at us because they know it's those freaking mushroom guys that started another fire. So we actually tested the material here. We did a lot of work on figuring out the properties of actually how you could use mycelium to replace different products. And we decided that we would launch a building material, a grown building material to replace the plastic used in building construction. And there comes a time in every startup's life where you really have to stretch. And that time for us came 2 years after we founded. We traveled to Amsterdam for a competition that actually wasn't based around mushrooms, but I do think it gave us an advantage. And we competed for €500,000, and it was a winner-take-all prize for the technology that the Dutch felt could have the biggest impact on climate change. And the Dutch are really worried about this, right, due to the sea level issues, so they're investing money in it. And against all odds, we actually won this competition. So this is my co-founder, Gavin McIntyre here. He's like insanely happy. And I was really happy for about 30 seconds, but that like look in my eyes is actually fear. Because we just stood up in front of all these people and said how we're going to impact climate change, how we're going to commercialize this mushroom technology and really have an impact on the planet. And for for some reason, they gave us €500,000 and said, go do it. So I was scared. This is actually a clip from CSI New York. So as a company, we created a material that won us €500,000, right? This green insulating board. And for some reason, the writers from CSI New York wrote us into their script against all odds. So we had like the world's greatest product placement in history. They're burning the styrofoam. They're talking about how our material is a crime solver here, right? So not only is it environmental, it fights crime, solves mysteries. all around, it was a really good bit. Yeah, so this was on CSI New York. So we did what any reasonable company would do that won, money to commercialize an insulating product, had a great product placement. We pivoted. Totally changed our business model, totally changed our product. And we did this because we realized, the best entry point for this probably wasn't building materials. Plastics take millions of years to create. They take thousands of years to get rid of. Building materials, they actually last a fair amount of time, maybe 100 years. So it's not the worst, most egregious use of the material. In some cases, it's a good use. But the same material is used in protected packaging, and it's used for weeks or months rather than years. So we went after packaging, the styrofoam used in packaging. And we created mushroom packaging, all the same attributes, but different market segment. And we went to work. We rented a 5,000 square foot warehouse, which was scary again because I signed a 7-year lease when we had about a year's worth of payments available. And we filled it with equipment. We were team engineers. We built hoppers to hold our incoming materials. We built this production system, and we started selling. And amazingly, we convinced a furniture company to start shipping in this material in 2009, which was really an act of pure belief on their part. And it was scary. Steelcase was the first. Yeah. And it was scary for us because we went from making 1 or 2 or 3 of these things in our labs to making thousands a month. And I, of course, bravely told them no problem, and then went back to my team and said, all right. And we filled the molds and emptied them, and we did it, though. And the next year, like a good living organism, we tried to replicate this model. We put in bigger racks. We expanded our facility. And last year, we started shipping with Dell. And now the servers that go to big internet companies in the Valley are actually shipped in mushroom packaging. And we continued to grow this. This spring, we moved into a 25,000 square foot warehouse. We built what is now, I believe, the world's most state-of-the-art mushroom facility. And we built a great office for our team. But we realized to really scale this, it wasn't good enough to just build a plant in Troy, New York. It wasn't good enough to build a bigger plant in Troy, New York. The impact we want to have is really global. So this summer, actually, we partnered with the enemy, or who was the enemy, Sealed Air, and licensed them this technology. Because it actually turned out that while they provided a lot of protected packaging solutions, they didn't make styrofoam. And they've committed to building plants across the US and building them in Europe with us. And it's going to let us focus on the technology. So I'm really excited about this. And thankfully, it means I can pivot again. So 5 years later, I'm back, and next year at Ecovative, we're going to be launching a building material again because we've had a lot of practice growing small molded mushroom shapes. Now we're quite excited to grow really large ones. So that's a little bit on Ecovative, a little bit on thinking about how do you see the uncommon beauty in common things, the magic that is life around us.